So we start a new unit today. This is Chapter 9, and in Chapter 9 we are going to look at different polygons and different shapes, and we're going to find the perimeter and the area of those shapes. So in Section 9.1 we're looking at the perimeter and area of triangles and quadrilaterals. Now we spent a lot of time in Chapter 6 dealing with different types of quadrilaterals. You'll recall that a quadrilateral is a four-sided figure. A triangle, of course, is a three-sided figure. You're going to need to understand the difference between finding the perimeter and finding the area. Okay, when I want the perimeter of something, I'm walking around the outside of it, okay, or I'm adding up the outside side lengths. Okay, it says perimeter is the total distance around the outside of a figure and is found by adding the lengths of the edges of the figure. Okay, so if I want the perimeter of this parallelogram, okay, parallelogram, remember, has two pairs of opposite sides are parallel. To find the perimeter, I'm just going to add the four sides together. I'm just adding those four sides. And one thing we know about a parallelogram is that opposite sides are congruent. So if they give you a measure of one side, you'll know that the other side that's opposite of it is the same measure. Same thing with the top and bottom. They would be the same measure. Okay, so the perimeter of a triangle, we're just going to add this side. We'll add it to this side. We'll add it to this side. We would add the three sides together to find the perimeter. If I'm finding the trapezoid, a trapezoid is a quadrilateral, so we're going to add the four sides together and we'll have the perimeter. Or the kite. The kite is another quadrilateral. We're going to add the four sides together. So with any figure, any polygon or any figure, to find the perimeter, we're going to add up the outside side lengths. Now you're also going to be asked to find the area. The area is the space that's inside the figure. So if you were going to paint or color the inside of it, that's what we're trying to find with area. And so we have different formulas for finding the area of different figures, different polygons. When we talk about a parallelogram, we just use area equals the base times the height. Now you have to be careful because the height of the figure is not always one of the side lengths. So we have the base, which the figure typically sits on, and then you'll notice the height is not on the outside. The height is straight up and down, the shortest distance between the two opposite sides. That is the height that we use. So it wouldn't be a side length. This side right here is not the height. You do not use that outside side. You use the vertical height of the figure. And it's just base times height. For a triangle, we use 1/2 base times height. So we take that base, here again is the base of the triangle, here's the height of the triangle, and we would take half of that. Okay? A trapezoid, this is one you may not have seen before, but a trapezoid has a formula that looks like this. Okay, it says area equals, I usually see the 1/2 times the height times base 1 plus base 2. That's what I usually see. I usually see the 1/2 and the height together. Okay, but these are all the same formulas. Okay, the height again, just like with the parallelogram, the height is the distance between the two parallel sides. So it's not going to be the slanting side here of the trapezoid. It's going to be straight up and down. That's your height. Base 1 and base 2, these are your parallel sides in the trapezoid. Whichever two sides are parallel, one of them is base 1, the other is base 2. And it doesn't matter which one. You can flip-flop those. But you're going to substitute those, and then we would do what's inside parentheses first. And then we would multiply times the height and times 1/2. And then lastly, we have the kite. And to find the area of a kite, this is something I haven't seen a whole lot, but the area of a kite is 1/2 diagonal 1 times diagonal 2. Recall that the kite, to create a diagonal, you go from one corner to the opposite corner. That length is one of the diagonals. They called it diagonal 1. And then to get the other diagonal, that would be diagonal 2. And again, those two values can be flipped around. But that's how you find the area of a kite. Okay, you've got a worksheet to work on that you can apply those formulas. Keep in mind the difference between perimeter and area. Perimeter is the distance around the outside, so just add up the side lengths. And to find the area, you're going to use one of these formulas depending on the shape that you're finding the area to.